Hothouse, Earth. Here's what the science actually does and doesn't say. A new scientific paper proposing a scenario of unstoppable climate change has gone viral. Thanks to its evocative description of a hothouse Earth, much of the media coverage suggests that we face an imminent and unavoidable extreme climate catastrophe. But as a climate scientist who has carried out similar research as myself, this is an article written by Richard Betts, Met Office Fellow, Professor of Climate Impacts, University of Exeter in England. He says much of the media coverage suggests that we face an imminent and unavoidable extreme climate catastrophe. But as a climate scientist who has carried out similar research as myself, I'm aware that this latest work is a lot more nuanced than the headlines imply. So what does the Hothouse paper actually say, and how did the authors draw their conclusions? First, it's important to note that the paper is a perspective piece, an essay based on knowledge of the scientific literature rather than new modeling or data analysis. Leading Earth system scientist Will Steffen and his 15 co-authors draw on a diverse set of literature to paint a picture of how a chain of self-reinforced changes might potentially be initiated, eventually leading to a very large climate warming and a very large sea level rise. One example would be the thawing of the Arctic permafrost, which releases methane into the atmosphere. As methane is a greenhouse gas, this means the Earth retains more heat, causing more permafrost to thaw, and so on. Well, one of the things that was found in the melting permafrost of Siberia recently was the mammoth, the woolly mammoth that they took the DNA from and they want to bring back from extinction. They want to create a Jurassic Park-like theme park with extinct animals that they found in the permafrost. Anyway, going back to this methane greenhouse gas, that the Earth retains, it means that the Earth retains more heat, causing permafrost to thaw, and so on. Other possible self-reinforced processes include the large-scale dieback of forests, the melting of the sea ice, or the loss of ice sheets on land. Hothouse or stabilized? Steffen and colleagues introduced the term hothouse Earth to emphasize that these extreme conditions would be outside those that have occurred over the past few 100,000 years, which have been cycles of ice ages with milder periods in between. They also present an alternative scenario of a stabilized Earth where these changes are not triggered and the climate remains similar to now. The authors make the case that there is a level of global warming which is a critical threshold between these two scenarios. Beyond this point, the Earth system might conceivably become set on a pathway that makes the extreme hothouse conditions inevitable in the long term. They argue, or perhaps speculate, that the process of irreversible self-reinforced changes could in theory start at levels of global warming as low as 2 degrees Celsius above pre-industrial levels, which could be reached around the middle of this century, and we're already at around 1 degree Celsius above pre-industrial levels. They also acknowledge large uncertainty in this estimate, and they say it represents a risk-averse approach. A key point is that even if the self-perpetuating changes do begin within a few decades, the process would take a long time to fully kick in. It would take centuries or millennia to kick in. Steffen and colleagues support their suggestion is of a threshold of 2 degrees Celsius through reference to previously published scientific work. These include other review papers which themselves draw on wider literature and an expert elicitation study, quote-unquote, in which scientists were asked to estimate the levels of global warming at which tipping points for these key climate processes might be passed. I was one of those consulted. The authors argue that 2 degrees Celsius can still be avoided if humanity takes concerted action to reduce its warming effect on the climate. In a similar way that the hothouse Earth scenario involves huge changes in the climate system with multiple effects of one process leading to another, the concerted global action to avoid 2 degrees Celsius would, they suggest, also involve huge changes in the human system, again with several fundamental steps leading from one change to the other. And don't ignore the caveats. Personally, I found this an interesting and important think piece that was well worth reading. Because since this is not actually new research, why is it getting so much coverage? I suspect that one reason is the use of the vivid hothouse Earth term at a time when everyone's talking about heat waves. Another is that it's clearly a dramatic narrative, and not surprisingly, this has led to some sensationalist articles. With some exceptions, much of highest profile coverage of the essay presents the scenario a definite and imminent. As definite and imminent, the impression is given at 2 degrees Celsius is a definite point of no return, and that beyond that, the hothouse scenario will rapidly arrive. Many articles ignore the caveats that a 2 degrees Celsius threshold is extremely uncertain, and that even if it were correct, the extreme conditions would not occur for centuries or millennia. Some articles do, however, emphasize the more tentative nature of the work, and some push back against this overselling of the doomsday scenario, arguing that provoking fear or despair is counterproductive. One thing that strikes me about the scientific literature on tipping points is that there are a lot of review papers like this that end up citing the same studies and each other. Indeed, my colleagues and I wrote one a while ago. There's a great deal of interest, insightful research going on, and using theoretical methods and calculations with large approximations. However, we have yet to see an equivalent level of research in the highly complex Earth system models which generate the kind of detailed climate projections used for addressing policy-relevant questions by the Intergovernmental Panel on Climate Change, that's the IPCC. Stefan and colleagues have made a good start at addressing such questions, going as far as they can on the basis of the existing literature, but their essay would motivate new research to help narrow down the huge uncertainties. This will help us see better whether hothouse Earth is our destiny or just mere speculation. In the meantime, awareness of the risks, however tentative, can still help us decide how to manage our impact on the global climate. This is on the conservation, and I'll leave links below for you for this.